Good morning, everyone. Welcome to the meeting for the AgRobotics Working Group. I know Kristen had said that the wrong agenda was attached to this, but if anyone has any issues with that, just let me know. We also are updating the working group funding priorities. Like I said in the last meeting, if anyone has any suggestions or comments on that, please let me know, send it my way, and we'd love to add anything in that would work for the group. It's also uploaded on the last meeting on the working group website, so you can look at it there if you don't remember where that is, or reach out to me and I'll be able to send you a copy. I'm currently working on a page that'll be dedicated on as well, so we'll hopefully have a separate section on the website for that. And just check and see if they did come in now. Nope, they currently aren't. So I would like to introduce the two members, which will also be presenting today. We have Joran Galou. Pardon me if I did butcher your name. They are from Vitirover, and he's the project manager. So if you want to introduce yourself a wee bit.
Yeah, so my name is Joran Galou, as you said. I'm a PhD student at the University of Roma, and I'm working with Vitirover on the academic robot. My work is mostly focused on developing the academic robot, and also for the research part on research on robotics for agriculture. Sébastien is also there from Vitirover. Maybe Sébastien, you can introduce yourself also.
Yes, hello everybody, nice to meet you. I'm Sébastien, I'm the director of sales and marketing for Vitirover. I've been with the company for about a year now and working on structuring the sales network around the world. And thanks to Chuck, we were invited to this meeting, so thank you very much.
Fantastic. If you'd like, you can move into your presentation now.
That's fine. I will just start with an introduction to the company and the robots we are producing and selling. And then Joran will take over with a more detailed and technical presentation.
Fantastic.
I'll try to share my screen. Is that working for everyone?
Yep, you're good.
Okay, so this is a picture of our professional commercial all-terrain robotic mower, initially designed and developed for wineries, as you can see in the picture. And since then, we have evolved to several markets. We have this video here that I can show you. Oops, sorry, there is a link that I need to get. You will be able to see the robot working in different environments. Can you see the video? So as you can see, we can now work in solar power plants. This is the robot in just a general vegetation. We can cut the grass close to trains as well, where currently it's pretty dangerous for people to work. This is in an orchard. This is apple trees orchard. As you can see here. We'll see the winery. As you can see, the robot is all-terrain with the back axle as cameras. You will have, this is the inventor of the robot. A quick view of the web application to use and manage the robot. And that's in the vineyards. The target is to go as close as possible to the vines. So that's our company, Vitirover. The company was created in, that's the name of the studio who created the video. The company was created 14 years ago now. Lots of research and development has been made on the robots. And the latest one, I'm trying to share that again, but that screen. Okay, are we back on the presentation?
Yep, you're good to go.
Okay, so a lot of research and development was made during the past 14 years. Today we have two different models. One is to work outdoors in the vineyards, orchards, solar plants, what I just showed you. The other one is the academic robots for high schools, engineering schools, universities. That's the project Jean will be talking about. This is a quick overview of our web application to manage the robots. We have geofencing that we just defined a plot for the robot to work on. Thanks to a very simple interface, we can track the battery, the motors, all the functions of the robot on this web application. You can see that here in more details. And as far as autonomy, the robot with its own solar panel can work up to 6 hours a day. If we wanted to work more, we have developed this additional charging station that will give the robot 16 hours of work every day after charging for 8 hours. And this charging dock station can be tuned with solar panels as well if you are in the middle of orchards or vineyards, with an additional battery here, electricity storage. We use one robot for 1 hectare, 10,000 square meters. And that station can be shared between two robots. This is a picture in a solar power plant. You can see the charging station are connected to the main electricity production device. The robot is very simple. That part, Jean will probably tell you more about it, but we have not a lot of sensors, mechanical or IR or whatever sensor. We have made it very simple in order to be very robust. That's a quick view of the robot. As you can see, we have sub-assemblies for the cutting block, for the axles, for the panel, the cameras, and of course, the PC board. We are working for manufacturing with former Ford factory in Bordeaux, where we are based. This factory has been here since 1976. They have a very good experience of quality control, manufacturing, purchasing, and they have a good production capacity. So for us, it's a very good partner for mass production. Just regular warranty policies, after sales and service. That's as short as I could do before giving the micro to Jean. Thank you very much, everyone, for listening.
Thank you.
All right. Thank you, Sébastien. I'll share my screen now. Okay. Can you see the presentation?
Yep.
Okay. So I will talk about the Vitirover Academic, which is a platform used for learning how to code and also for robotic and research. So I'll start with a brief introduction of the academic robot, and then I will present the two studies I worked on using this platform for research. So as Sébastien said, the robot is very simple but very robust. It's mostly thanks to the mechanic of the robot. It's mounted on a universal joint for the rear axis, And this axle is responsible for the stability and also the steering of the robot. We are applying a difference of velocity on the two rear wheels to make the robot steers, and it's a four-wheel drive robot also. It's powered by a heavy-duty battery and also solar energy, giving up to 16 hours of work, which is quite convenient if you want to work in a vineyard or for research to have a long time working span. It's also embedding some sensors, IMU, GNSS, RTK cameras. And also for the academic robot, we have included the Jetson Nano to be able to use any algorithm you want, even some AI algorithm if you wish. For the coding, we also made the platform easy to use and with different coding languages, such as Scratch, that you can use directly on the cloud platform that Sébastien presented. You can also use Python and C, C++. For the academic robot, we also made the robot ROS compatible, and it's available on our GitHub page. I can share the link later on if you wish. And we also have a gazebo simulation of the robot that allows you to test your algorithm before implementing it on the real robot. So now I'll present the first study I did, which is the vineyard rose detection. First, I'll present the context, a bit of the context, and then data collection, and finally we'll move on to the rose detection. So this study was made in France, in the vineyards of Saint-Émilion, in the southwest of France. As I said, the robot is with four-wheel drive and a front cutting tool equipped with IMU and GNSS. So the robot is navigating in the vineyard and it's eventually colliding with the trees because the main goal of the robot is to cut as near as possible to the trees. So when there is a collision of the trees with the robot to the trees, then we record a peak in the IMU. This peak allows us to save the location using the GNSS RTK. Then we sorted the data to keep only the collisions with an accuracy of 5 centimeters for the GNSS. So once we had all the locations saved, we were able to superpose them with Google Maps view. So here we can already see the pattern in this sparse data set. We can already see more or less the rows. Maybe you don't, but I do. And the goal is then to detect automatically the rows using only this data set. So to do so, what we did is that we drew a line between all set of all pairs of data in our data set, and we were seeking for the most intersected line in drawing this line between two pairs of data of coordinates. And once we had the most intersected line, we were able to get the slope of the row. And then the goal was to detect the spacing between the rows. So we use the same technique. We shift this first line centimeter by centimeter, seeking again for the most intersected line. And once we had this line, we were able to find the spacing of the rows, giving us the vine rows that you can see on the second image. I'm not showing it here, but we also conducted a validation part where we went in the fields with centimeter poles to record the slope of the rows, and we compared this slope with the one that we detected, and we had less than 5% of errors. So it completely validated the model, the algorithm, to automatically detect the rows. A second project was MPC for width targeting. MPC stands for Model Predictive Control. So we had to first derive the kinematic model of the robot because the robot is quite peculiar, and in the literature so far there were no derivation of such a kinematic model. So with the the lab I'm working on, we derive the model, and then we design a MPC framework. And finally, I will present the gazebo simulation that we did to validate this model. So in order to get the kinematic model, we consider the non-rolling and non-sliding constraints to be able to get the description of the motion. We were able to get a relation between the angular and linear velocity of the wheel's rotations. So for given angular and linear velocity, we can give a wheel rotation specific for each wheel. And for the trajectory description, it's the Ackermann model with the rear axle steering. The MPC framework was used to control the robot. So MPC is working by continuously predicting future states of the robot and then optimize at each time step the performance and also while ensuring the constraints. So the constraints can be on the motion of the robot or also obstacles on the way or a trajectory to follow. The prediction states are computed using the equation of motion, so the Ackermann model in our case. And for this research study, the innovative part was done on the dynamic weights in the objective function of the MPC. So we adapted the weights for the weeds depending on the distance from the robot to the weeds. So the first task was to follow the path. And then when the weeds were on the field of view of the robot was deviating from the path to reach the weeds. So here we have an overview of the trajectory of the robot. So in red is the trajectory that the robot is supposed to follow to cover the vineyard. It's the land mower trajectory, land mower path. And in black, we have the actual trajectory that the robot performed in order to reach the weeds on its path. The picture down there is the picture of the robot in gazebo, where we can see here the robot deviating from the trajectory to reach the weeds represented in white here. So we were able, using this simulation, to first validate the kinematic model using the URDF of the robot and the kinematic model we derived. We also validated the MPC formulation and the innovative part, which was the dynamic weights to target the weeds on the paths. So that's it. That's a very brief overview of the research project that can be performed with this robotic platform, the academic Vitirover. If you have any questions, I will be pleased to answer them.
I did see there was one question, but it was already answered in the chat, but I'll just read it out just so everyone knows that. Do you require manual plug-in for your solar docking, or do you have anything that makes it autonomous as well? And the answer is the solar charging dock station is autonomous, yes. It has its own solar panel and accumulator. Any other questions for?
Yeah, I have one. Do you need a robust cell or internet connection to run it?
Yes, all the data that the robot will collect will go to a cloud through a GSM connection, and the other part is actually to define the plots. We do that through the web application, and this is sent to the robot through the GSM connections.
And I think that's something, Giuliano, is when we think about like remote areas for weed management, there are some vegetation management companies that are very interested in this. And one of the first ones we want to try it at is a railway station down in Windsor.
Right.
So they're going to have good connectivity. And but once we move kind of away from, if we move up north or something like that, connectivity becomes an issue. So I think we got to focus on, the the sort of populated areas first. You know, most of southern Ontario should be good enough.
Yeah, okay, thanks.
Any other questions? I saw Kristen has her mic unmuted.
Hi. Hi, thanks very much for the presentation. Really interesting. I was wondering what other commodities that you've worked in or have any data from? What other crops?
I'm not sure I got the questions. The question, I'm sorry for my English, but you mean the type of fields in which we operate? Yes.
Yeah. Are you just working in perennial systems like orchards and vineyards and in terms of the cropping systems or anything else?
Oh, right. We work in solar power plants. We work in electricity power plants, transformers, electricity transformers. We are running some tests on railway side tracks, as well as highways. The side of the highway, we have worked with airports. And lately we have started to work with horse racing courses as well. We don't go to golf courses or baseball fields and stuff like that, where the grass needs to be very clean and the ground is very flat, because we have lots of competition doing that very well today. But we are specialized in fields where it's a little chaotic, rough, and that's where we can make a difference, because we have four-wheel drive and our axle, fully free axle that can help going through obstacles, basically.
And how high is the grass need to be? I mean, at what length will it not perform adequately?
Well, yeah, that's a very good question. We are a maintenance robot. We are not like cutting when it's really high vegetation.
Yeah.
So once, usually what we do, we install the robots after the last time the owner has cut the grass with its regular way of cutting the grass.
Right.
And then we maintain the grass between 5 and 15 to 20 centimeters. The robot will permanently be on the plot, so it will never leave. And because of that, the grass will always stay short, and the robot will keep doing a good job over time. But you're right, the first time we install the robots, we need to make sure the field is prepared first.
Right.
I was just curious with some of the other people on the group, what they thought of Sharon's presentation on the modeling tool, and whether that's something that people have experience with or would be interested in. I'm just curious. Seeing silence.
It's a lively crowd this morning.
I thought that was a pretty neat option to be able to test some stuff out and see how it works.
Yeah, for my case, for the study I conducted, it was very convenient to have a simulation, to not need to go in the field, and also you can gather more data through a simulation. And then the next step of the work I did is to go in the real field and test what I did in reality. And by the way, the second project is currently submitted for a research publication. So we'll see what it will give.
How long do the blades last before you need to sharpen them, or are they self-sharpening, or how do you deal with that?
Actually, they are not sharpened. It's like a thin steel blade. You don't have to sharpen them. We have a double rotation design that makes them strong when they hit like a rock or something hard. And the cutting is done thanks to the speed, the high speed. I think it's 3,000 RPM. And because we keep the grass short, again, it's young vegetation, and it's actually cutting pretty well without need for sharpening. When the field is like without a lot of stones, we can the blades can last for like a year or even more. When you have stones and rocks on the field, you probably will have to change them twice or 3 times a year. But we are, because they are not sharpened, we are on pretty cheap blades kits actually. So
If the grass is wet, does it still work, or you recommend it when it's dry?
well, I was in a demo yesterday all day actually on a kind of a trade show, and in the morning, you're right, the grass was really wet. It was cutting, but not as well as in the afternoon when it was dry. It was doing a really better job, but it was still working in the morning. So of course, more efficient when it's dry.
How often would you have to go back over it? Like once a week, once every 2 weeks? Or does it just depend on how quickly everything grows?
We leave the robot on the field permanently, so we will define like a plot for the robot, approximately 10,000 square meters, and then it will maintain it forever, let's say. So if there is no issue, if the robot doesn't send an alert because something is going wrong, you don't have to go back. It will take care of the field by itself.
So that's your gauge, and it's 10,000 square meters per robot.
Yeah, that's an average, but of course it will depend on the number of obstacle, trees, vines, the angle, I mean the slope, but the average is that, yes, correct.
What's its capacity with slope or gradient? Like how steep of an incline can it go up or down?
For regular work, we recommend no more than 20%. It can go higher, but like through an obstacle, for instance, shortly. But if the entire field is more than 20%, it will actually spend a lot of energy just to climb, and it won't be very efficient in the cutting and the surface. So we don't recommend to install it over 20%.
We have a question in the chat here as well. It says, what's the cost of one? Do vineyards tend to buy more than one?
Yes, on the quantity, people actually buy one per hectare per 10,000 square meters. As far as price, the public price is around 8,500 euros. In France, of course, because abroad you have shipping expenses and custom clearance and all that stuff. So, but at least here in France, we are public price is around 8,500 euros.
Fantastic. Any other questions? No. Thank you very much for your presentation. It was very insightful.
Well, thank you for inviting us. Thank you very much.
Glad to have you as part of the call and joining the working group going forward as well.
Thank you. That we would be happy.
Sure, yeah. Thanks.
No problem. So on to our next agenda item is events and demonstrations. So just recently, it actually finished just yesterday, was the Ottawa Farm Show. Did we have any attendees? I was supposed to go up, but I couldn't make it. Anyone present? I don't think Kelly's on the call either right now, so no. Okay. We'll get someone and get an update on that. I'm sure I'll hear feedback from it next week. And then we also have the World Agri-Tech Innovation Summit, which is coming up March 19th to 20th, and that's in San Francisco. The New York Organic Summit, which is the 3rd to 5th of April in Syracuse, New York. Agri-Tech Venture Forum, which is on the 1st and 2nd of May, and that's going to be in Toronto. And the International Symposium on Robotics and Automation, which is on the 22nd of July in Manhattan, Kansas. I'm going to be putting all of these up on the website as well, so if anyone wants to get more information on them, they can get them there. Project updates. We are completing our annual report right now, so I'm hoping to have that out to you next week. This will go over all the events that we've done as a working group in the last bit and promotion and all the research data and everything along those lines, just kind of giving a brief overview. So really excited to get that out to everyone. We'll be posting that on our website, and I'll be sending out an email when we do have that up and available. It'll be available both in English and in French. If anyone has any questions on that, please let me know. And for funding announcements, nothing too much has been updated from the last time we went through. This is another area where I would like to create a web page on our website so that all this information is prevalent and accurate going forward. So hoping to have that out there soon. I do know that the ATII will be closing soon, and I do believe the Greenbelt also has to have their letter of intent in by the 22nd, which is coming up very soon.
Aaron, I was just wondering if maybe next time you could add to that list the app that the NSERC folks were talking to us about last week. Yeah. Because that was really, really great resource with all the funding, even municipal funding in there that I didn't know about. So that's awesome.
There's a lot of money out there. You just have to know about it. Yeah, no, I will absolutely get that out to everyone. And then I guess we can shift over to our round table. Does anyone have any items that they'd like to bring up or thoughts?
Yeah, I do. I just wanted to let everybody know that the European Parliament just passed their landmark Artificial Intelligence Act, which is establishing the world's most comprehensive set of regulations for AI tech. So here's a few highlights of that. Newly banned AI apps include biometric and facial recognition on sensitive characteristics, social scoring, and AI that manipulates behavior or exploits vulnerabilities. High-risk AI, such as in infrastructure, education, and employment, will face strict obligations like risk assessment, transparency, and human oversight. The law has drawn the criticisms from both sides, with companies worrying it will stifle competitiveness and watchdogs arguing it doesn't go far enough. So the rules will take effect in stages, with some applying as early as 6 months and after the law enters into enforcement. So why does this matter? Well, the AI Act there positions itself as the global standard now for regulation, but will it disadvantage European Union-based AI companies in the process? So that's we're gonna have to continue to watch that to see what, outcomes that will bring. And also another big story this week in the Egg Founder, the data is showing that there's a decline of almost 50% in agri-food tech funding around the world in 2023. With sharp declines in every category except bioenergy and biomaterials and farm robotics, mechanization, and equipment. So they're wondering if 2024 will deliver even lousier numbers, or if this is the perfect time to invest in a leaner, meaner new wave of startups. So it's going to have to watch that, because we all know, like, in terms of startup funding, it's it's really needed by a lot of these companies. So have to be watching that.
Can I just comment on that?
Yeah.
I saw the same report, and from our industry, because we do deal with vertical farms and greenhouses, and we were impacted greatly by that. But what we're finding now for 2024 is our customer base is coming back. So the large farms aren't, as far as, like, couple of years ago, we had $1 million contracts with vertical farms, and they're not coming back at the moment. But what we're finding is all the smaller farms are buying the equipment they need without going overboard. And so I personally think it's going in the right direction, and it's definitely going up on a curve, which I think is totally positive in the market. We're seeing a lot more action now than we were 6 months ago.
Okay, good.
Chuck, you have a item?
Well, I always have something for the round table. So I came across a manufacturer who has built a small electric tractor, and they are they have one that's readily built. What they're looking for is a place to use it. And so this electric tractor is about the size of a Farmall A, to give people an idea of the scale of what it can do. They built it. He's built it with two 3-point hitch arms, so it can lower implements to the ground. And the idea of this electric tractor is that, you know, it'll have a target cost that's very, very low. You know, he's tried to make this using automotive and industrial components that are already mass produced. So, you know, kind of, I guess what I'm looking for from the group is, you know, the guy is looking for a place to use it. I prefer it to be somewhere within an hour of Haggerty because he wants us to support it. He is working with the University of Waterloo on an autonomy kit for this tractor. Essentially what he wants it to be able to do is a person would drive a route and that would map the route. And then when they're done, the robot could just refollow that exact same route. So they're not, you know, he's not trying to be too advanced. And I'm thinking that a couple of use cases that would work good, if you guys know a grower that would be interested, would be somebody who has a transplanter. So someone who has a person who is either walking behind a transplanter or riding on a transplanter, that would be a good use case. That kind of thing. So if you guys have an idea, let me know. Like, of course, at Haggerty, we could always just put a lawnmower underneath it, but I don't think that's the best use case for a machine like this. So so just I guess reach out, let me know if you know of somebody that might be interested.
That's good. Any other items that anyone would like to bring up?
Well, just that I read that FEAR this year is going to be free for growers to attend. So they've realized that they're not getting enough growers there, so they're going to make the event free. So hopefully they can get more participation from the grower community to you know, participate and see all the new tech.
And I
I
did
saw that as well.
I did also see there is another conference coming up in November, which I do believe is in Hawaii, for drone conference, I do believe. So RPAAS.
Yeah, I'm sorry. I shared that in the link. It's Kyle here.
Yeah.
That is a conference I attended last year to give an update on the drone-based pesticide application regulatory experimentation project that we were doing. But it's a really good conference for those that are sort of interested in the drone space. And this year it's happening in Hawaii, so that makes it. I don't think I'm going to be able to go, but if anybody wants to go to Hawaii and take in all that knowledge, it's a good option.
Fantastic. And I also saw you linked out to the AI regulations for Canada as well.
Yeah, Kristen's. I was reading that stuff about the EU regulation as well, and you know, I think it's good to sort of stay on top of where things are at with that, and there is sort of a similar process going on in Canada that's not obviously quite as evolved, but just thought groups here might be interested in following that.
Absolutely. Appreciate you putting that in the group. Any other items? No. Okay, well, thank you all for joining us. I really appreciate that. We'll hope to have the annual report out to everyone next week. And that'll be just going through the final reviews here and then getting it all pretty. But yeah, hope to have that out and looking forward to the next year as well with all of our projects that are starting to come into fruition. Thank you. Have a great weekend. Oh,
You're muted, Kristen.
you're muted, Kristen.
Yeah, sorry. I just want to ask anybody, has anybody heard anything back from any of the funding applications that were submitted? I'm just curious. No? Okay.